Video number 3 in Unit 1. In this exciting episode, we'll be covering dimensional analysis, which is essentially converting. In science, we like to use the metric system because it is superior to the imperial units or the American units that many of you have grown up with. For length, our base unit is meters. For mass, it will be grams. And for volume, liters. Here's a list of all the metric prefixes. Some of them you've probably never heard of, and some of them we need to know for the class because you're going to use them a lot. The ones that I need you to memorize starts with kilo. 1 kilometer or kilometer is 10 to the third meters. Other ones that come up frequently are centa, which you know, there's 100 centimeters in a meter, or 1 centimeter is 10 to the negative 2 meters. If you look over to the side, the little exponent is what we're going to use for conversion, so that's what you have to remember. So a millimeter is 1,000th of a meter, micro is a millionth, nano is a billionth, and pico is a trillionth, or as they say in England, a millionth. Okay, here's 3 steps for doing dimensional analysis or converting problems. Take a moment and read through those, but we're going to go through them one at a time as we look at an example. Okay, so our example is we have 4.32 times 10 to the negative 4th grams, and we're going to convert to micrograms. If you look back at that table, micro is 10 to the negative 6, so we're going to use that as a conversion factor, and you see there at the bottom we have it 2 different ways. We can flip that fraction over depending upon what unit we're trying to cancel. Step 2, derive the appropriate unit factor by looking at the direction of the required change. So we want the 10 to the negative 6, the grams in the denominator, so that grams cancels and we're left with micrograms, which is what we're looking for. Multiply the quantity to be converted by the unit factors to give the quantity with the desired units and correct sig figs. And we have 3 sig figs in our final answer. Okay, another example. Convert 231 millimeters to nanometers. Here we're going from one metric prefix to another. When we do that, I want you to go back to the base unit. So we're going to take 231 millimeters, and the base unit is meters. The conversion factor, if you look back at that chart, is 10 to the negative 3. 10 to the negative 3 meters goes in the numerator, and then millimeters in the denominator, so that millimeters cancels. Please remember that the 1 always goes with the prefix. When you're looking at that table, the 1 goes with the prefix. So millimeters has a prefix that gets the 1. So that gets us back to the base unit, which is meters, and then we do another step to get to nanometers from meters. So the 1 goes with the prefix, so 1 nanometer, and then from that table, 10 to the negative 9 is the conversion factor for nano. Meters cancels meters, and we have 3 sig figs. If you stab at your calculator, we get 2.31 times 10 to the 8th. And if you're having difficulty entering this into your calculator, let's make sure we're entering it correctly. If you have a graphing calculator, when you enter the exponent, use that EE function on your calculator, which is the second function on the comma typically. On that note, Miss Kim is making a video where she's going to instruct you on how to enter things into your graphing calculator. If you're not familiar with that, you might want to watch that. Okay, a little more involved problem. The moon is 250,000 miles away. How many kilometers is it from the Earth? And gosh, I don't know a conversion factor between miles and kilometers, so we're going to come up with another plan here. Okay, so we need to come up with a plan. We're going to start with miles, and I'm going to use some conversion factors here. If you don't know the US or the imperial conversion factors, that's fine. You can always ask. The only ones you're going to be held responsible for is metric conversions. But in this case, I know how to go from miles to feet, and then feet to inches, inches to centimeters, centimeters to meters, and meters to, what am I looking for again, kilometers? Kilometers. The conversion factor between miles and feet, I want miles in the denominator, feet in the numerator. There are 5,280 feet in 1 mile. And then to inches, I want feet in the denominator, so it cancels. Inches in the numerator, there are 12 inches in 1 foot. And now we're going to convert from inches to centimeters. So inches in the denominator, centimeters in the numerator. There are 2.54 centimeters in 1 inch. And now we're back to our metric that we have to have memorized. We want centimeters down here, and that has a prefix, so I know a 1 goes with that. And there are 10 to the negative 2 meters in 1 centimeter. That is an m. And the last step, we're going to cancel meters and get to kilometers. 1 goes with the prefix. 10 to the third meters is a kilometer. I know that's awful. Now, before you start stabbing at your calculator, let's make sure all the units cancel except for the one that we're looking for. Miles cancels miles. Feet cancels feet. Inches cancels inches. Centimeters cancels centimeters. Meters cancels meters. Hey, look, we're left with kilometers, and that's what we're asked to find. Stab, stab, stab. I want an answer to 2 sig figs, so we get 4.0 times 10 to the 5th. If you don't have your calculator in scientific notation, may have got 400,000. Now, you might be thinking, how do I express that to the correct number of sig figs? Because this looks like 1 sig fig. The easiest way is to put it in scientific notation and put 4.0. But if this is my last sig fig, then I can just put a line over that. The next problem in our notes is we have 75 miles per hour, and we're going to convert that to meters per second. So in this case, a little different than the last problem, we have a unit in the numerator and the denominator. So we need to come up with a plan. What I would like you to do, and this will help you not make silly little mistakes, is come up with a plan. We'll start with miles. We have to get to meters. So miles to feet to inches to centimeters to meters. Okay, that takes care of the numerator. And then I know nobody knows how many seconds there are in an hour, but you do know how many minutes there are in an hour and how many seconds there are in a minute. There's your plan. Why don't you go ahead and attempt the problem, pause the video, and we'll see if you can get the right answer. Okay, welcome back. Let's see if you have it set up right and if you got the right answer. There's all your conversion factors, making sure all your units cancel. So the only units left should be meters in the numerator and seconds in the denominator. Our original measurement had 4 sig figs, so you should give me an answer to 4 sig figs, 33.53 meters per second. Okay, this problem is a little bit different. We're converting 7.2 cubic millimeters to cubic centimeters. Now, I know that you do not know how many cubic millimeters are in a cubic centimeter, but we do have length conversions that we can use for this. So we're going to start with our 7.2 cubic millimeters. 1 millimeter is 10 to the negative 3 meters, but again, that is a length conversion, not volume. So we're going to put a cube outside the parentheses. That means both the numerator and the denominator are being cubed. And we're going millimeters back to the base unit, meters. And then one more step from our base unit to centimeters. 1 centimeter is 10 to the negative 2 meters. That second conversion is also a length conversion, so we have to cube it. Cancel your units, stab at your calculators, and you should get 0.0072 cubic centimeters. Okay, another problem, and I know you're enjoying these and we just can't get enough. Lake Michigan holds 1.3 times 10 to the 15th gallons of water. How many liters is this? So your conversion factor here is there are 3.79 liters in 1 gallon. Okay, so we have 1.3 times 10 to the 15th gallons, and we're going to convert to liters. So we want to have gallons in the denominator so that it cancels, liters in the numerator. And there are, I bet you don't know, there are 3.79 liters in 1 gallon. Gallon cancels gallon. Simple multiply, you get 4.9 times 10 to the 15th liters. Okay, word problem. I know you love these. An individual suffering from high cholesterol level in her blood has 285 milligrams of cholesterol per 100 milliliters of blood. If the total blood volume of the individual is 5.3 liters, how many grams of total blood cholesterol does the individual contain? Okay, before we flip over to the whiteboard and start solving this problem, I would like to point out anytime you're reading a word problem and you see the word per, I want you to think conversion factor. So in this case, 285 milligrams equals 100 milliliters of blood. That is a conversion factor that will allow us to go between the mass of the cholesterol and the volume of blood. Okay, so sometimes the hardest thing with a problem like this is where do I start? And you could actually start as one individual, but that one individual contains 5.3 liters of blood, so there's really no reason to multiply by the 1. I'm going to start with the 5.3 liters. And I have come up with a plan here. I know that I have to get my liters to milliliters so that I can then use this as a conversion factor to get to mass. Once I do that, then I can take the milligrams and convert to, this is actually a G. I know my writing sucks, but you'll get used to it. That is a gram. Okay? So 5.3 liters. I want liters in the denominator, milliliters in the numerator. The 1 goes with the prefix, 10 to the negative 3. Hopefully you're referring back to that table and you're getting these memorized. The only ones you have to memorize is the metric. Okay? Now I've canceled liters and I am at milliliters, so I can use this conversion factor. Milliliters is going to cancel milliliters. Milligrams, so 285 milligrams in 100 milliliters. So there my milliliters cancels my milliliters. I am now at milligrams of cholesterol, and I'm going to convert to grams. That's a G. Milligrams in the denominator, so milligrams cancels milligrams. The 1 goes with the prefix, so 1 milligram is 10 to the negative 3 grams. Take your bony little fingers and stab at your calculators, and you should get 1,500 grams. 2 sig figs, because I don't know if I've talked about this earlier in the notes, but for our conversion factors, these are considered to be infinitely precise. We only look at our initial measured quantity for determining sig figs. This had 2, so I want my answer to 2 sig figs. Okay, another word problem. The recommended adult dose of elixophyllin, registered trademark, a drug used to treat asthma, is 6 milligrams per kilogram of body mass. Note that that's probably a conversion factor because I said per. Calculate the dose in milligrams for a 150-pound person. The conversion factors here, we have to go from pounds to grams. Pounds, no, we can go directly, we have a conversion factor to go pounds directly to kilograms. So that is on your formula chart. It is 2.2 pounds per kilogram. I would like you to try and set this up, pause the video, use that 6 milligrams per kilogram as a conversion factor, start with a 150-pound person and get to milligrams. And go.